Hello everyone, and welcome. The world around us is built from chemical elements. Most of them are essential for modern life, supporting everything from medicine and technology to agriculture and energy production. Yet among these same elements are a small number that can pose extraordinary dangers when people are exposed to them under the wrong conditions. Some damage the nervous system. Others attack vital organs. A few release powerful ionizing radiation capable of damaging living cells at the molecular level. In today's video, we'll explore 7 of the world's most dangerous elements based on well-established scientific research. We'll examine what makes each element hazardous, where it is found, how it affects the human body, and why scientists continue to study or use these elements despite their risks. One important point before we begin. The danger of any element depends on several factors, including its chemical form, the amount of exposure, and whether it enters the body through inhalation, ingestion, or direct contact. Under carefully controlled conditions, many of these elements have valuable applications in medicine, scientific research, and industry. Our goal today is to understand the science behind these remarkable substances. Now, let's begin our countdown. Number 7, Cadmium. Our countdown begins with cadmium. Cadmium is a soft, bluish-white metal with the chemical symbol Cd and atomic number 48. Although relatively uncommon in nature, it is produced as a byproduct during the mining and refining of zinc, lead, and copper. Cadmium has been widely used in rechargeable batteries, metal coatings, pigments, specialized alloys, and certain industrial processes. The danger comes from its toxicity. Unlike some poisons that produce immediate symptoms, cadmium often accumulates inside the body over many years. Because the kidneys remove it very slowly, repeated exposure can gradually damage these vital organs. Long-term exposure has also been linked to weakened bones, lung disease, and an increased risk of several types of cancer. For this reason, the International Agency for Research on Cancer classifies cadmium as a known human carcinogen. Today, strict workplace regulations and improved industrial safety have greatly reduced exposure, but cadmium remains one of the most carefully monitored toxic metals in modern industry. Number 6, Lead. At number 6 is one of the most well-known toxic elements in history. Lead, with the chemical symbol Pb and atomic number 82, has been used by humans for thousands of years because it is dense, durable, and easy to shape. Ancient civilizations used lead to manufacture pipes, cookware, cosmetics, paints, and many other products, long before scientists understood its harmful effects. Today we know that lead is a powerful neurotoxin. Once it enters the body, it can interfere with the normal function of the brain and nervous system. Children are especially vulnerable because they're developing. Brains absorb lead more readily than adults. Even relatively low levels of exposure can affect learning, memory, attention, and cognitive development. In adults, prolonged exposure may contribute to high blood pressure, kidney damage, reproductive problems, and disorders of the nervous system. Because of these well-established health risks, many countries have removed lead from household paint, gasoline, plumbing systems, and numerous consumer products. Despite these changes, lead continues to be used safely in certain industrial applications, including radiation shielding, specialized batteries, and scientific equipment, where strict safety procedures help minimize exposure. Number 5, Arsenic. At number 5 is an element that has gained a notorious reputation throughout history. Arsenic has the chemical symbol As and atomic number 33. It occurs naturally in rocks, soil, groundwater, and volcanic regions, meaning small amounts are present throughout the environment. Certain forms of arsenic are extremely poisonous. Acute exposure to high doses can damage multiple organ systems, while long-term exposure has been associated with cancers of the skin, lungs, bladder, liver, and other organs. In some parts of the world, naturally occurring arsenic contaminates groundwater, making access to safe drinking water an important public health challenge. Although arsenic is highly toxic, it also has important scientific applications. Certain arsenic compounds are used in semiconductor manufacturing, and some carefully controlled arsenic-containing medicines have been successfully used to treat specific forms of leukemia under close medical supervision. This demonstrates an important principle in science. Many dangerous substances can still provide significant benefits when used correctly, in precise amounts, and under strict professional supervision. We've now explored 3 highly toxic elements whose dangers arise primarily from their chemical effects on the human body. But the next 4 elements introduce another level of danger. They include one of the most powerful neurotoxins known, followed by radioactive elements capable of releasing enormous amounts of ionizing radiation. Let's continue the countdown. Mercury takes the 4th position on our countdown. Mercury has the chemical symbol Hg and atomic number 80. It is unique among metals because it remains in a liquid state at ordinary room temperature. Its bright, silver appearance fascinated scientists for centuries, and it was once widely used in thermometers, electrical switches, fluorescent lamps, scientific instruments, and industrial equipment. Today, scientists understand that mercury is one of the most dangerous naturally occurring toxic elements. The greatest concern comes from a compound known as methylmercury. Microorganisms in lakes, rivers, and oceans can convert inorganic mercury into methylmercury, which then enters the food chain. As small aquatic organisms are eaten by larger fish, mercury becomes increasingly concentrated through a process known as bioaccumulation. Large predatory fish such as shark, swordfish, king mackerel, and some species of tuna may contain significantly higher concentrations of mercury than the surrounding water. When humans consume excessive amounts of contaminated seafood over long periods, mercury can accumulate within the body. Mercury primarily attacks the brain and nervous system. High levels of exposure may affect memory, coordination, vision, hearing, and muscle control. Developing fetuses and young children are particularly vulnerable because their nervous systems are still forming. Despite these dangers, mercury continues to serve valuable purposes in carefully controlled scientific laboratories and specialized industrial applications where strict safety procedures greatly reduce the risk of exposure. Number 3 is radium. Radium, with the chemical symbol Ra and atomic number 88, is a highly radioactive alkaline earth metal discovered in 1898 by Marie and Pierre Curie during their pioneering research on radioactivity. When radium was first discovered, its remarkable glow fascinated scientists and the public alike. Unfortunately, the health risks associated with radioactivity were not yet fully understood. In the early 20th century, radium was added to luminous paints used on watch dials, clocks, and aircraft instruments. Workers who painted these dials were often instructed to shape their paintbrushes using their lips, unknowingly swallowing tiny amounts of radioactive material. Many later developed severe illnesses, including bone damage, anemia, and cancer. Their tragic experiences became some of the earliest evidence of the harmful effects of long-term radiation exposure. Radium behaves chemically in a way that resembles calcium. When it enters the body, it can become incorporated into bones, where it continuously emits ionizing radiation. This radiation damages nearby cells and increases the risk of bone cancer and other serious diseases. Although radium is rarely used today, it played a critical role in helping scientists understand radiation biology and establishing the modern radiation safety standards used around the world. At number 2 is plutonium. Plutonium has the chemical symbol Pu and atomic number 94. It is a synthetic radioactive element produced primarily inside nuclear reactors through neutron capture reactions involving uranium. Several isotopes of plutonium exist, each with different properties and applications. Plutonium-239 is widely known because of its use in nuclear weapons and certain types of nuclear reactors, while plutonium-238 has been used to generate electricity for spacecraft exploring distant regions of our solar system. Although plutonium emits mainly alpha radiation, which cannot penetrate human skin, it becomes extremely dangerous if tiny particles are inhaled or swallowed. Once inside the body, plutonium can remain in the lungs, liver, or bones for many years. During that time, it continuously releases ionizing radiation capable of damaging DNA and increasing the risk of cancer. Because of these hazards, every stage of plutonium production, transportation, storage, and scientific research follows some of the strictest safety procedures in modern science. Highly specialized containment systems, remote-controlled equipment, multiple layers of shielding, and continuous radiation monitoring help protect workers and the surrounding environment. Despite its hazards, plutonium continues to play an important role in nuclear science, energy research, and space exploration when handled responsibly by trained professionals. Finally, we arrive at the number 1 position. Polonium-210 is widely regarded as one of the most dangerous radioactive substances known. Polonium has the chemical symbol P and atomic number 84. Polonium-210 is an extremely powerful alpha-emitting radioactive isotope. Outside the human body, alpha particles travel only a very short distance and can even be stopped by a sheet of paper or the outer layer of human skin. However, if polonium-210 enters the body through inhalation, ingestion, or an open wound, the situation changes dramatically. Because the radioactive source is now inside living tissue, it can deliver an intense dose of radiation directly to nearby cells. This damages DNA, destroys healthy tissue, and may lead to severe radiation sickness affecting multiple organs throughout the body. Even extremely small quantities can present a serious health risk if internal exposure occurs. Fortunately, access to polonium-210 is tightly controlled worldwide. It is produced only in specialized nuclear facilities and handled under rigorous safety regulations designed to prevent accidental exposure. Although exceptionally dangerous, polonium has also been used in specialized industrial applications, including certain static electricity elimination devices and scientific research. Our journey through these 7 elements reminds us that danger in chemistry is never determined by fear alone. It is determined by evidence, careful scientific measurement, and a clear understanding of how each substance behaves. Cadmium, lead, arsenic, mercury, radium, plutonium, and polonium each present unique hazards, whether through chemical toxicity, radioactivity, or a combination of both. Yet each has also contributed to important advances in medicine, industry, technology, and scientific research when handled under carefully controlled conditions. Modern laboratories, industries, and research facilities operate under strict international safety standards that greatly reduce the risks associated with these elements. These regulations, combined with decades of scientific research, help protect both workers and the public while allowing these remarkable materials to continue benefiting society. Thank you very much for watching. If you enjoyed learning about the science behind some of the world's most dangerous elements, please consider giving this video a like, sharing it with others, and subscribing for more science-based documentaries exploring chemistry, physics, astronomy, and the remarkable discoveries that continue to shape our understanding of the universe. Thank you again for your support, and we look forward to seeing you in the next video.